Welcome. In this lesson, we're going to combine everything we've learned about ellipses, and we're going to find all the different types of corresponding things of an ellipse. Now, sometimes the equations are very simple. We do not have to do a process called completing the square. All we need to do is add the 54 to the right side, divide everything by 54 to make sure we're always equal to 1, and 18 goes into 54 3 times. So our standard form of our equation is x squared over 54 plus y squared over 3 equals 1. And now just remember, here is the standard expression of our equation. We always find our a by taking the square root of the larger of the two numbers, so that our a value is the square root of 4. Our b value is the square root of the smaller of the two numbers, so the square root of 3 is our b value. Our C length is going to be always the larger minus the smaller. 54 minus 3 is 51, and we square root it. Now that allows us to find all the information we want. If we want the center, this one has a horizontal and vertical shift of 0 each, so our center is 0, 0. So that's what I'd type in for this problem. If it asked me for the vertices, I would add and subtract the square root of 54 from the center's x value, because the x, it's horizontally longer than it is vertically. So I added and subtracted square root of 54 from the x value of the center to find the vertices. To find the co-vertices, I add and subtract the square root of 3 from the y value, because the co-vertices are above and below the y value. If I was asked to find the foci, I would add and subtract the square root of 51 along the major axis, or along the a value. So that's horizontally, so I'm going to add and subtract the square root of 51 from the 0 and from the center to find the foci. Again, this one was fairly simple because we didn't have to complete the square. The next one we do, we'll have to complete the square. So in this problem, we had to complete the square. Basically what I did was I moved all the terms to the left side of the expression except the 72. I left that on the right. So I have a y squared. Now be careful, I had a minus. That means it's plus, so I minused it over. Then I completed the square. I had to add 9 to this 2y terms to get a perfect square trinomial that happened to be y minus 3 squared, because remember that 3 is always half this value. Keep the sign. I didn't have to complete the square on the x, divided by 81. That tells me my a value is 9. No, my a value is, oh yeah, sorry, yes, my a value is 9 because I square root the larger number. Square root of 81 is 9. My b value is 3. Square root of 9 is 3. And then if I needed to find the foci, I would do 81 minus 9, which is 72, and square root it, which reduces to 6 square roots of 2. Now I have the information. I can find the center, which is what this one asks for. The center has a vertical shift of 3 and a horizontal shift of 0. So 0, 3. If I was asked to find the vertices, I would add and subtract 9 from the y value, because this is elongated vertically. It's larger underneath the y. So I'd add and subtract 9 from this 3 to find the vertices. If I was to want the co-vertices, I'd add and subtract 3 from the x value. If I wanted to find the foci, remember it's along the a value, or along the major axis, I'd add and subtract 6 square roots of 2 from 3. Add it once and subtract it once, not changing the x, to find the foci. In this one, we need to complete the square twice. So the first thing I did was I brought everything to the left side except the negative 44. And I grouped the x's together and I grouped the y's together. Then I had to factor out the 2 from the 2x squared and the 8x. That gave me an x squared plus 4x. I had to factor out a 3 from the 3y squared and the 36y. That gave me the y squared plus 12y with the 3 factored out. I left a space because now I need a number that makes these 3 terms a perfect square. Or I take half of 4, which is 2, and then I square that to find this missing number. Now I added 4 to the right side that I needed to times by 2. 2 times 4 gives me the 8 that I added to the right side. Again, I had to take half of 12, which is 6, square 6, that gives me 36, which really I added 108, so that means I had added 108 to the right side, which gives me 72 on the right side, and these 2 perfect squares that have been factored. Now I divide by 72. 2 goes into 72 36 times. 3 goes into 72 24 times. So my standard form of my equation is x plus 2 squared over 36 plus y plus 6 squared over 24 equals 1. This tells me this is elongated horizontally. The number under the x squared is longer. Square root of 36 is 6, so my a value is 6. Square root of 24 reduces to 2 square roots of 6, so my b value is 2 square roots of 6. To find c, I take 36, I minus 24, that gives me 12. I square root it, and that gives me 2 square roots of 3. Now I'm able to find every part of this, or every property of this ellipse that it ever asks for. If it asks for the length of A, or length of B, or length of C, if it asks for the vertices, its center, right, its center is -2, -6. So if I wanted to find the vertices, I would add and subtract 6 to the x value. So the vertices would be a -8, -6, and a 4, -6. If I wanted to find the co-vertices, I'd add and subtract 2 square roots of 6 from the b value. So I'd add 2 square roots of 6 to a -6 and subtract it. From the b value, I'd keep the x value the same. If I wanted to find the foci, I would actually add and subtract 2 square roots of 3 from the x value, since it's elongated horizontally. So -2 minus the 2 square roots of 3, comma -6 would be 1 foci. -2 plus 2 square roots of 3, comma -6 would be the other foci. This problem happens to actually ask for the major axis, length of the major axis. That's just double A, so I just have to type in 36. Again, if you have any questions, please do bring them to class and I will help you. It's not 36, it's 12. I can double 6. Double 6 is 12, not 36. I squared it. That was my simple mistake. Doubling does not mean square. Again, if you have questions, please do bring them to class.